So we have the integral from 0 to c of 18x plus 8 dx equals 372. We want to find what c is. C is an upper bound of the integral. So one way to do it is just to gut it out using algebra. So we integrate. You get 9x squared plus 8x. You just plug in your c. And when you plug in 0, they drop out. So that part can be pretty much ignored. So you have 9c squared plus 8c equals 372.
Oh, okay.
And then you just bring it all to the left side. And you've got yourself a quadratic here. And I would not waste time trying to factor this.
Mhm.
This is the quadratic formula. So it's going to be negative 8 plus or minus 8 squared, take away 4 times the first and the last, all over 2 times the first. So it's going to be a mess. Let me get my calculator here.
Mhm.
On the inside here, we have 64 plus, the minuses will make plus 4 times 9 times 372. 1, 3, 4, 5, 6. So you get a crazy number.
Oh, and then also just in the question, it says assume that c is greater than 0. So
Right. Yeah. Yeah, you're gonna get two guys. Actually, this works out to be a perfect square.
hmm,
It's actually plus and minus 116. So you end up getting two answers here. One of them, well, if it's, I'll write it out. One of them would be negative 8 minus 116 over 18. And the other one would be negative 8 plus 116 over 18. And we don't want the negative one, so we'll just use this guy here. So I'll do it real quick. You get 6.75. Okay. And apparently that's what we want. So I can show you a geometrical way. If you graph the function, it's going to be a line and it's going to pass through 8. And it's going to have a steep slope of 18. So I'm going to kind of fudge it a little bit. Going to kind of go up like that. Anyway, at 6.75, if you were to integrate from 0 to 6.75, you're going to get an area, you're going to region. That area would be that 372 that was given. Okay. Does that help?
yes. Thank you.
Sure. What was the part that you were stumped about? I'm just curious.
It was mostly just looking at it and freaking out that I had to find C.
Okay.
So
Does it
just
make sense? Does it make sense now?
yep.
Okay. Are there any other questions on this one? Okay. Um, any other questions? So this is the initial temperature at 6 a.m. is 40.6 degrees Fahrenheit, I assume. And
Yes.
it's changing at this rate. So this is actually a rate function. So the units of R is degrees per hour. And I've seen this question pop up a few times in the discussions. I bet you the first one wants to know like at 10 a.m., right?
Yes, at 10 a.m. I know how to
So
do that one. I just get confused on the last like 3 ones that it asks.
not a problem. Let's go ahead and do it all. At 10 a.m., that's just an easy plug and chug, right?
Yeah.
T is 4. So you just plug in R, T is 4. I'm sorry, R 4. And I'll say just so everybody knows, always be in radian mode. Anytime you do analytical trigonometry, it's always radians. You pop a 4 in there, you get pi over 3. I'm gonna go ahead and punch that out real quick on the calculator. 3.26 cosine pi thirds plus 0.039. I just get 1.6. Actually, I'll just round it up, 1.7 degrees per hour. All right, and I wanted to emphasize that because the units are important. It's degrees per hour, it's a rate function, so that tells us just to plug it in. But in the second question, it actually asks for the actual degrees, right?
Yes, it goes from 6 a.m. to 1 p.m. last Sunday, and then what's the temperature increased by?
Okay, so between 6 a.m. and 1 p.m., that would be the same as t equals 0 to t equals 7, right? Because 1 p.m. is 7 hours later.
Yeah.
And the question asks for degrees, and that's a hint. So to go up from a rate function to a non-rate function, an accumulation function, you have to integrate. So that was your hint. The hint then is to integrate from 0 to 7, 3.26 cosine pi over 12 t plus 0.039 dt. So you just need to work out that integral. Now, did you get anywhere with that when you were doing it, or was that stumping you?
No, that's dumb because I followed it a different way when we had it on the homework assignment, and then I got lost from there.
Okay. You know, I will say this. This is not a hard integral to work out, but you know what? You can graph this on your calculator. And do you ever do the second calc integrate feature on your calculator?
I don't know. I have the TI 84 plus, so if it's on there, it probably is.
Oh yeah, it's definitely on there. It's a really sweet little tool. So you graph this, and then you do second calc integrate 0 to 7, and it'll actually shade in the area for you, and then tell you the answer. The problem is if I put my calculator on the screen, it glares out. It doesn't. The camera and the calculator just glare out. So I'll just go ahead and do it analytically. So the antiderivative of cosine is sine. The 3.26 is just a um, constant multiplier. The pi 12 has to be divided out because we have to balance. That's that quick RDR substitution. So it's actually going to be 12 over pi sine pi 12 t plus 0.039 t from 7 to 0. And when you plug in 0, everything drops out. So it's just a matter of plugging in 7. And this is a mess, I agree. That's why I was suggesting your calculator can punch this out too. If you plug in 7, you get 7 pi 12ths plus 0.039 times 7. So I'm going to just do that real quick. So 3.29 times 12 over pi times p sine of 7 pi 12ths plus 0.039 times 7. And I get 12.4 degrees. That's the change. And you add that to the original 40.6. So evidently the degrees now will be, I guess you borrow one, boom, 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 53 degrees. Okay. So far, so good?
Yeah.
Okay. Part 3, can you remind me what it was?
It says, what is the temperature in the park at 1 p.m. last Sunday?
Last Sunday. Oh, I think that's what we just answered right here, right?
I think so.
Yeah, yeah. Okay, so part 2 was to get the actual change in degrees. Part 3 was to, I'll just copy the answer. It was what is the actual temperature? All right, so that was easy. Then the last one's like 5 days later, right?
Yes, it's at what is the temperature in the park at 4 p.m. last Friday, 5 days later?
All right, so the tricky part here is this 0.039 is like a separate constant. It actually raises the rate ever so slightly every day. Otherwise, this is cyclical, and you wouldn't have to go through those 5 days, but we're going to be forced to do the full 5 days. So it's going to be the same function. The good news is we've already done a lot of the hard part. We just copied it. We need to find the change in temperature, and then And then we'll add it to the 40.6. So it was, I'm sorry, remind me again what time? 4 p.m.
Yes, 4 p.m.
on Friday, right?
Yes,
So we have to
Friday.
figure out how many hours later is that. So Sunday, that'd be Monday, Tuesday, Wednesday, Thursday, Friday. That's 5 full days plus an extra 10 hours. So 5 times 24 plus 10 is 130. So that's our upper bound. Okay. So I'll make a note of that. It's 130 hours between Sunday at 6 a.m. and Friday at 4 p.m. Well, you know what? It's the same antiderivative. So I'll copy it. Oh, jump the gun there a little bit. Pi 12. So I'm gonna go ahead and just pop in the 130 plus 0.039, 130. And again, when I put the 0 in, it just drops out. So if I work all that out, let me do it real quick. I get 11.35. Or I'll just round that to 11.4. So we add that to the original 40.6. And you get 51. And again, those get 0, so 52 degrees. Alrighty. Does that make sense?
It does. I just need to hopefully remember how to do that for tomorrow's exam.
Yeah, and again, I don't mind using calculators. I mean, to me, it's it's kind of knowing what to do, and if you do it analytically by hand, and then you want to check your calculator, that's a good idea too. YouTube has all sorts of videos on the TI-84 Plus, and if you just like type in like TI-84 Plus integrate, and just watch like a tutorial,
Okay, good to know. Thank you.
definitely recommend it. Alrighty, any other questions on this one? All right. This is one that came up. Let me share it. This one came up in the discussions on the board here. I'm going to copy the graph. It's a half circle, then a triangle, and a straight line. And these are units of A, 2A, 3A. The function was F. And the graph, well, it said here, if A is 6, find negative A to 3A of f of x dx. And this one I think kind of caught people a little off guard because I think they were kind of confused by the notation. So this is a good one to know. So one thing that I want you to know about integration is its area. Integration talks about accumulation. We view accumulation in the context of graphing as area below a curve. So you don't need to get fancy here. You don't need to actually do any fancy anti-differentiation. This is deliberately it's an ugly function, but it serves a purpose, which is to kind of emphasize that if you just know some of your geometry area formulas, that a problem like this is actually quite simple. So remember, integration is area. All right. And so I'm going to use geometry formulas here. So for the half circle, well, the area formula for a circle is pi r squared. So half of that is half pi r squared. And in this case, A is 6. So we just pop in a 6 into the r. You get 36 over 2, which is 18. So you get 18 pi. All right. That's the area of the half circle, 18 pi. Down here we have a triangle. the area of the formula of a triangle is 1/2 base times height. So the base is 1. The height, be careful here, is -1. Because I'm going down below the x-axis. So the area is actually going to be -1/2. And then for the little square here, or rectangle more generally, it's just base times height. Again, base is 1. Actually, you know what? I made an error here. I can fix that real quick. The base is actually A, and the height is A. All right, you know what? Let me just do that real quick. I'll do it right here. A and -A. So it's negative, it's 1/2 times 6 times -6. So -18. All right, I'll make the fix here. It's base is A, height is -A, so just negative. So 6 times -6 is -36. Okay. Sorry about that. I was thinking in terms of just units. Then we just add them up. It's 18 pi. Then we plus, but you're plussing some negatives here. So it's -18 minus 36. And the system wants you to enter in a value. So I'll just type it in. And I get 2.5487. That's the net area. There's more stuff above than below. That was a question that popped up a couple times. I thought that was a good one. Make sure tomorrow on your test that you know your antiderivative forms. Just, you know, the power rule, the chain rule, a couple of integration by parts, things like that. Those are going to be, you're going to be asked a lot of questions. You want to know your basic trig ones, sine and cosine mainly. So just practice those. Any other questions? All right. So we have function population is increasing by this rate. T years since 1990. So T0 is 1990. We're told the population 90 was 5,100. We want to find the population in 2020. So we're going to integrate. And so we antiderivative, 37 just is a spectator. We have to divide by the 0.018 e to the 0.018 t. Let me simplify that coefficient in front. I get 2055.55. There's going to be a plus c. Okay. And that plus, go ahead.
Oh, no, I was just,
Okay. Because this is an indefinite integral. So there's a plus c. And that's where the initial information here comes into play. We were told that so what we have here is a function p of t. Notice that the original function is p prime. We now have a function called p of t, which is the actual population. This is the rate. This is the actual, which is 2055.55 e to the 0.018 t plus c. And I know that at 0, well, what happens when you plug in 0 here? You get 0 in the exponent. E to the 0 is 1. And we know that that's supposed to all equal 5,100. So that allows me to solve for c. I have 2055.55 plus c equals 5,100. So I can do a quick subtraction. I get 3044.45. So the full function is 2055.55 e to the 0.018 t plus 3044.45. So that's the actual population model. Okay. So they want to know the population in 2020. So we're going to plug in T would be 30 years. So we just pop a 30 into the model and see what magical number we get.
Okay, that makes more sense now.
Let me go ahead and I'll go ahead and finish this off. Let me do it. I'm curious now. So I get 6571.78. And we want to be nice to these people, so we'll round it to the nearest whole number. And there you go.
Thank you.
Yep, no problem. Does that make sense to other people? Any questions on that one? This is another question. It's similar. It's not identical, but it's similar to a question that's come up in the discussions. This is an integration by parts integral. And the general formula for integration by parts is, so here integral UdV, it's UV minus integral V du. The integration by parts is the product rule worked backwards. Sometimes people get stumped. They don't know when to use it. It looks an awful lot like U to U substitution for the chain rule. My suggestion is try it. Try U to U first. If it doesn't work, then do it as integration by parts. Now this one is a little tricky because it's actually nested. It means we're gonna have to do integration by parts 2 or 3 times, and that gets real ugly. So in the discussions forum, a couple people asked a question like this, and I showed them a method called tabular integration by parts. And I want you guys to see something like this. So I'll write it out. I'll say it's integration by parts. This is going to require multiple steps. So we're going to use tabular method. It's basically a shortcut so that we don't have to go through the whole rigmarole every single time. And the problem being, of course, is that just more opportunities to make mistakes. So what you do is you take your 2 parts, you make a couple of columns. One column you're going to integrate, and the other, I'm sorry, my bad. The first column, I should say, you're going to differentiate. The second column, you're going to integrate. And you're going to differentiate until you're down to 0. Okay? So just keep on going. So 6t squared plus 8 is going to 12t, then 12, then 0. Okay? In the corresponding entries over here, you anti-derive the function until you hit that line with the 0. And then you stop. Okay? And then you draw arrows kind of like in a diagonal like this. I'm going to draw them light. And you alternate the signs. And then you just piece it together. It's really cool. So you take like this arrow here, you get 6t squared plus 8 times 1/2 e to the 2t. Then this one here, you're going to get negative 12t times 1/4 e to the 2t. And then this guy down here, you're going to get plus 12 times 1/8 e to the 2t. And then, of course, a plus c. And that can actually be simplified a lot. For example, right here, the 6 and the 8 and the 2 make 4t squared, I'm sorry, 3t squared plus 4 e to the 2t. Here you just have 3t e to the 2t. And here you have 12 over 8, which is what, 3 over 2? E to the 2t. And if you really want to, you could factor out that e to the 2t, although it doesn't matter at this point. And that's your answer. So no parts. It's really nice. For a related question that seems to pop up a lot, something like, if I can remember, it was like 2x cosine 3x. And this one doesn't need I'm sorry, my bad. It doesn't need tabular. It does need integration by parts. You can actually do it the same way I just did right here. Just differentiate down to 0. And then just do your arrows. You always kind of go in a diagonal like that. Plus and minus, in this case, you're going to get 2x over 3 sine 3x. And then here you're going to get negative of a negative, so it's going to be plus. So 2/9 cos 3x plus c, and bada boom, you are done. Isn't that nifty? So tabular is a real time saver.
Can we always use that method when it asks for integration by parts?
You sure can.
Oh, yay.
I mean, it's exactly the same method as this formula, as the formula up at the top. It's just a kind of like a visual way to write it out that I think most people find kind of, it's almost like an algorithm. You know, if you were to go through slowly and work it out using the formula and you're careful with it, you should get this. I guarantee you will. I mean, but this is the same method.
Okay, thank you.
Yep. Go ahead and, yeah, very good, very good. Sorry about that. So this question, they gave us the functions and they gave us where they intersect. And really all we're interested in is the x values where they intersect, because those are going to become our bounds of integration. If you didn't have, if this wasn't given, let's say you're just given the two functions, then what you need to do is you need to graph them. You need to find where they intersect. So I'll write that as a note, just kind of an alert. If the graph is not given, then you've got to graph the functions and find where they intersect. And again, on your calculator, use the second calc intersect, should be intersect. Let me type mine in. Be, second calc, yep, second calc option 5, intersect. And if you're not sure how to do that, go through again a quick 3-minute YouTube tutorial. And it'll tell you all about it. It's really easy. It's actually pretty intuitive. I like the TI. It's actually always been a very intuitive calculator. All right. Here we're given the bounds. So we're going to step an integral, lower bound to upper bound. And when you do an area between curves, you always do the top minus bottom. So the top curve and the bottom curve is always going to be top minus bottom. So actually the top curve, believe it or not, is this g function. And then you subtract off the bottom one. And that's your integral set up, okay? Yeah, nasty looking. All right, let's clean it up just a little bit. I'll go ahead and distribute the minus sign. You get negative x to the 4. I'm sorry, yeah, and then plus 8x cubed. Take away 21x squared. And then this guy pops in negative 22x plus 120 dx. This is just using the power rule about 5 different times. Let's see. 2 is going to be 11x squared plus 120x, all from 3 to negative 2. And if you're not, and again, always good idea to check your anti-differentiation by differentiation, all right? So if you weren't sure that how I got from here to here, you can check it by taking the derivative of this. You should get this back again. All right, so then it's just a matter now of plugging it in. And this is just going to be kind of tedious calculation here. Got to watch out for the negative sign. So got a lot of negatives to keep track here. -2 to the 4, take away 7, -2 to the 3rd, take away 11, -2 squared, plus 120, -2. And then you just kind of work that out. It's not difficult, it's just kind of tedious. I'll do it real quick. So for the first one, I get 185.4. The second one, give me a second here, Michelle. I get -189.6. Remember, there's a negative out in front of all that, so it turns out to be an addition. So 185.4 plus 189.6 works out to be 375 units. Now, I'll admit I kind of ran through that, so I hope it's correct.
That was the correct answer. Mhm.
Anybody want me to explain anything on that? So we want to find total area bounded by y equals x and y equals 1/4 x cubed. Now, if you graph them, y equals x is just the diagonal line here. Y equals 1/4 x cubed is going to be the cubic function is going to be kind of I would say it's kind of suppressed a little bit. It's going to look something like this. It's going to look something like that. So the curvy function is 1/4 x cubed. So the total area is going to be these little two wedges here. And what we need to do is find out where they intersect. So what we're going to do is set them equal to each other and solve for 0. So we're going to bring the x over. We can factor. Let's see. Actually, I don't like fractions. I'm going to multiply 3 by 4. I get x cubed minus 4x equals 0. I take out an x. I've got x squared minus 4 equals 0. And that works out pretty nice. So x is going to be -2 and 2. So we get a 0 here. So we actually have 3 intersection points. And it seems to make sense with the graph. It looks like 0 obviously is in the middle, -2 back here, 2 here. Now here we have symmetry. And so what I'm going to do is I'm going to figure out the area for the right side from 0 to 2. The top function is the x, the bottom function is the curve. And then I'll just work it out. So it's going to be what, 1/16 x to the 4th, 2 to 0, put a 2 in, so you get 2 squared is 4, 2 times 2 to the 4th power 16. Actually, that works out really nice. Put a 0 in, you just get 0, so you get 2 minus 1, which is 1. Oh, that was nice. And then the area back here is going to be the same. So the integral from -2 to 0, it would just be the function's reverse. Because now they switch positions top and bottom, but it's still going to be 1 because it's symmetrical with the area to the right. So the hardest question of the class all semester is 1 plus 1, it's 2, right? So that's the total area between the two curves. That help, Landon? Awesome. Alrighty. We've got 10 minutes. I can maybe do another one, maybe 2 if they're quick.
Can I ask one more question?
You sure can.
Okay, I'm gonna share because it's a word problem.
Yep. Go ahead. During 21 weeks at the height of the influenza outbreak, the rate at which the number of cases of infection change could be approximated by, I hate when they do that, L prime of T, negative 6.54 T plus 142.5, where L is the total number of infected people. I guess it's I, isn't it? And T is the time measured in weeks. So let me copy that down. So we've got I prime of T is negative 6.54 T plus 142.5. And answer, so estimate IFT, the total number of people who have contracted influenza by, okay, we're assuming that I of 0 is 1394. Okay. So let me copy these real quick. So in the second case, we want to find how many people contract influenza in the first 8 weeks. So
It's mostly C and D that I was having issues with. The first two were okay to get the answers for. It was
okay.
just the last two.
Okay, let's take a look. Approximately how many people contract influenza during the whole 21 weeks? And the fourth one would be approximately how many people contracted influenza during the last 7 of the 21 weeks. So that would be during weeks 14 to 21, right? All right.
Oh,
Okay.
okay.
So I'm gonna go ahead. So I'm gonna can you go ahead and unshare perfect? So in the first case, because these go by really quick, you're just integrating. And you're gonna get, so you divide by 2. I'll just do that real quick. 6.54 divided by 2. So negative 3.27 T squared plus 142.5 plus C. Now I'm going to cheat here a little bit. I'm going to write in the C very lightly. Okay. But actually, it should be a T. There's a T there. When I plug in 0 and I set it equal to 1394, these two terms drop out and it makes C 1394. So I'm just go ahead and pop that in. So that's your function for I without the prime symbol. So I of T. Okay. The second question is just the first 8 weeks. So you just pop in an 8. Okay. Blah, blah, blah. The last two are going to be um, losing my mind here. You're going to want to integrate. So during the whole 21 weeks, let me think about that. We just did the integration. So we have 0 to 21. Actually, we just pop into 21. So we go from t equals 0 to t equals 21. So if I do 3.27 and then 21 squared plus 142.5 times 21. And then now here's the interesting thing is that when I put in the 0, the constant's actually going to cancel out. Okay, I'll show it to you. So I get 1394. And then when I put in the 0, well, check this out. These guys drop out anyway because they got zeros in them. And then the 1394 and then the minus 1394 take each other out too. So really, I just need to figure out what that number is. So negative 3.27 times 21 squared plus 142.5 times 21, and I get 1550.43. Now that's the change. That's the total change in cases. We know that it started off with 1394. So we add 1394. I guess I'll just round it 1550. I get 2944 total cases. Does that make sense?
I think it just wanted the 1550.
Oh, really? Okay.
Okay, so I think that's what I was doing. I was adding it, but it wants the first part where you
So
plug in.
the questions just simply say how many new cases or what was the change in cases? Because I forget what the question said actually.
Approximately how many people contracted influenza during the whole 21 weeks?
Okay, okay, that makes sense. Then that would be the 1550
Okay.
because it didn't say total. I guess, yeah, it's a little, yeah, I can see that. It just wanted to know during those 21 weeks, there were 1,550 new cases.
Okay.
And then for part B, you would do the same thing, except you would go between 21 and 14. So
Okay,
I'll
yep.
write
The
out,
14 was the one that, okay.
yeah,
That makes
let's do it real quick. So, um, sorry, I'm getting a little sloppy here. So it should be what all this works out to be. So I'm dying of curiosity. Let's find out. Um, and I get negative 398.79. Did I mess that up? I'll just round it up to 399. No, I guess actually that makes sense. Maybe the rate the number of people drop.
So the answer that it had was 196.
I wonder if I just made a mistake. Let me double check myself. Yes, I did. Okay. I find my error. Sorry about that. Yep, which is I did. You know what I forgot to do? I actually mistyped it. I didn't type in that square. Oh, how embarrassing. All right, even us professors make mistakes. Yep, I sure enough I get 196.35. What did you say the answer was?
Yep. 196.
They just rounded it.
Mm-hmm.
All right. Well, that makes me feel better. Hey, you know what? That's actually, I guess, a lesson learned because I got a number that just didn't seem to make sense. I was trying to make it make sense, but honestly, I didn't feel comfortable with it. I got a negative number. That's usually an indication I made a mistake. So if that happens to you, you
Mm-hmm.
get a number that just seems funny, take a look at your actual calculations. I wouldn't be surprised if you just mistyped something. That happens a lot. It's very easy to do.
At least now I know that the last 7 weeks means 14. That's what was throwing me off, how it was worded.
Okay. Well, I think that they were
Mhm.
trying to trick you. Well, guys, I'm gonna call it because it's almost 7 o'clock. I will, uh, record this and put it on my channel and then send out an email to everybody. Um, wish you all the best of luck. Get good grades tomorrow.